Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
Okay, so for this reaction, we want to complete the table for the reaction where you have Cl2 plus 3F2 forms 2ClF3. So this is our reaction up here, and we're given the change in our concentration of chloride over time. And what we need to do is fill in the rest of this table. So the first thing to start off this problem is to write out our rate equation. So our rate for this reaction is going to be equal to negative our change in concentration of chloride over time, which is going to be equal to negative 1/3 times our concentration of fluorine gas over time. There should be a delta here, and this is going to be equal to plus 1/2 times our change in concentration of our product, ClF3, over time. Okay, so now what we're given is that this change in Cl2 over time is equal to negative 0.012, which is this right here. So from this, what we can figure out is that our rate for our equation then is going to be equal to this. So our rate here is going to be equal to the negative change in chloride over time. So this is going to be 0.012 concentrations per second. Okay, so now let's look at F2. So F2, in this case, we have negative 1/3 F2 is equal to Cl2. So let's say negative 0.012 is going to be equal to negative 1/3 times, we're just going to call this x. So once we solve for x, these both become positive. We multiply this by both sides by 3 to get rid of these. And so when we multiply this by 3, we get a value of negative 0.036 molarity per second. And it's actually times negative 3 because we want to get rid of this negative charge as well. So now I'm going to use black for this last one. We know that the rate for, we'll call this y now. Okay, we'll call this y. Right, so we know that our change in Cl2 over time is equal to negative 0.012. It's actually times negative 1, and this is going to be equal to plus 1/2 times y. So in order to solve for y, we need to multiply both sides by 2. So y is going to be equal to 0.024. So 0.024 molarity per second. And if you kind of think about it and go back through, which you should always do anytime you are finishing up a problem, is that you want to check the signs. So the rate of the reaction should be a positive sign, which it is. And in terms of our rate expression, if you look here in green, you would want our two reactants, which in this case are Cl2 and F2, to have negative signs, which you can see here and here, because that makes sense because our reactants are decreasing over the course of the reaction. And now you want this to have a positive sign, our product, because this is increasing in concentration. And so if you look through, this should make sense.